Hey, this is Corey McCray, and this is my first network that I'm going to advertise online. Um, what we're going to do here today is we're going to have an EIGRP route and a RIP version 2 over frame relay. Here's the frame relay cloud. Here are 4 routers. We're going to call this one Atlanta, and we're going to call this one LA. I haven't figured out the names for these two yet, but we'll get there. Don't worry about it. And because of the complexity of this network, we're going to do this video in about maybe 3 or 4 parts. So right now, what we're going to focus on, we're just going to focus on this half of the network. And then we'll go here, here, and here. And every device on here will be able to talk. So it doesn't matter if this guy here is in Canada. Well, yeah, we're going to call that guy Canada. This guy in Canada will be able to talk to this guy over here over the network effortlessly. And I will illustrate that within these 4 videos. So we're going to get started. First off, on router 1, we need a serial interface. There's no serial interface to connect these 2 routers together. We're going to cable everything up first, okay? Wait. We're going to do this first. Let's do this. Let's worry about the LAN first. What we're going to do is we're going to come here and we're going to run a fast Ethernet cable here to here. That's done. After that, we come from this switch. We come from here to here. Next, we come from here to here. Everything is cabled up. Now, we need IP addresses here, right? So we have 2 VLANs here. This guy here is on one network. This guy here is on a different network because we're going to use a demarcation of a /24. So the first 24 bits stop right there where you see that 1 and that 2 before the last 2 ones. So what I'm going to do is I'm going to go ahead. I'm going to start creating VLANs on the switch. And while I'm doing that, we're going to do an enable. And then we're going to go show interface brief. Oops, sorry about that. Show interfaces. Fast Ethernet interface 1 is down because I didn't turn it on the router. So you always want to troubleshoot, and not necessarily troubleshoot, but know why the interface is down. And to see why the interface is down, you see it's Fast Ethernet interface 01. So let's go here. Fast Ethernet 01 is down. Why is it down? Because the router is probably down. So you go into the router, and once you come into the router, you tell them no, turn, enable, config, and which interface was that on the router? Let's double check. I forget sometimes. Sorry about that. 00 is on the router. So we're gonna bring that guy back, and we're gonna do a interface Fast Ethernet interface 00. We're gonna do, see how the lines are red? Both lines are red. That interface is shut down, so there's gonna be no connectivity there. We're gonna do a no shut. The line is now green. The interface is up. So what I'm going to do is I'm going to figure out what lines these are. I got this on 2, and I got the other one on 3. Obviously, I don't know why the mouse is doing that. So let's create some VLANs on here. All right, VLANs. You're gonna go config, interface VLAN. Say VLAN 1 should already be on here, so we're gonna say interface FA02 switch port mode access. That makes the access port, therefore you cannot trunk and throw VLANs across that port. And you're going to switch port access VLAN 1. So now that port belongs to this network. So the only people that can actually access anything on this network will be the ones in VLAN 1. So now we're going to go back out, and that was 2. So we know that interface phase 03 is going to be switch port mode access, switch port access VLAN 2. Well, VLAN 2 doesn't exist yet. Sorry about that. VLAN interface. Let's say VLAN 2 interface VLAN 2. and VLAN 2 is now up. So now let's go back in and try it again. Okay, interface FA03, switch port access, VLAN 2. Good, it works. So now let's also go back to interface VLAN 1, no shut. Protocols changed to up. So now we know which networks they belong to. So we know that this is on 3, so we're going to give them the IP address of 192.168.1.2 because we can't use the actual address that we're going to use on the interface up here. So we're going to come back, and then when we come back, we come back down to the PC. We go to the desktop. Once we go to the desktop, we're going to give him a 192.168.1.2. And I'm going to give him a demarcation of 255.255.255.0 and his default gateway, which is going to be this guy right here. He needs a way to get out. When he wants to talk to him, he's not going to talk directly through him to the switch. Switches don't make routing decisions. Everything is based off a MAC address. So this is going to be an IP decision when they talk to each other. And when it comes back down to switch level, then we'll get an ARP request, and then it'll find the address. So what we're going to do is we gave him an address, and we got to give him a name as well. I want to be able to see his name. VLAN 1, okay, V1 PC. So I know who he is. And then we're going to do the same thing here. Now, this guy is going to be, I'm pretty sure you've already guessed it, 192.168.2.2. And his default gateway, you guessed it again, 192.168.2.1. We come back out of that, and we tell him, feed to PC. That way I don't have to keep going inside the PC to see the address and all that hoopla. I don't feel like doing that. So these guys cannot talk to each other right now. There's no way that these computers can communicate because, like I said before, switches don't make decisions. So let's go ahead and test it out. Test my theory. We're going to ping from there to there. .2.2. Remember that guy? Nothing. When he pings, he sends the request out. The switch can't determine where it's coming from. So the switch, he can't talk to the guy at all. So he's going to get a request timeout every time. No connectivity. So we're going to come out of there, and when we come out, I'm going to go to router 3, and this is where all the decisions get made. This is the brains of the operation. Okay. So I'm going to say we're going to come. Oh yeah, one more thing I forgot. That line needs to be trunked or it won't carry both VLAN's traffic across the line. So let's go ahead and trunk that line now. Okay, exit. Okay, we're going to say interface fast Ethernet 0/0 because that is the interface number of that interface. So we go into that interface, invalid interface number. 0/1. It's not a router, sorry. Okay, so then we're going to say switch port mode trunk. So now that interface is up as a trunk. So he will carry the tags, the 802.1Q tags, and he'll carry those across and let this guy know who everybody is. We're going to do an interface FA 0/0.1 for VLAN 1. And we're going to say IP add 192.168.1.1. Remember that? And we're going to get a demarcation of 24 bits. 0. Oops. One more thing. Encapsulation. I always forget to encapsulate it. It always does that. I don't know why it does it every time. .1Q. Sometimes I forget the command. So then we're going to do IP add 68.1.1 and 24 bits. And then we're going to come out of there. And then we're going to do, and what I did, if you didn't notice, these are sub interfaces. There is no interface on that router. That is fast Ethernet 0/0.1. That is a sub interface to signify that this is a part of VLAN 1. So I'm going to create another sub interface for VLAN 2. FA 0/0.2. So then I'm going to encapsulate it. encapsulation .1q 2, and I'm going to give the IP address IP add 192.168.2.1 24-bit subnet mask, and no shut. The line is up. Now these computers will now be able to talk to each other. You don't believe me? Just watch. So this guy is PC1. I can remember the address of PC2 because I'm looking at it. I only gave it a, matter of fact, it's still there. So let's just do up arrow, ping. He doesn't get it at first, but then bam, 3 replies. Let's do it again just to verify, and he can talk magically. Those are 2 different networks, two different broadcast domains talking to each other. So we're gonna go here and we're gonna call this Atlanta, because this is now the Atlanta office. These guys are sitting at their desk and they're happy now. They can talk across the office. So I'm going to come back here, Atlanta. That's the display name. Atlanta can talk to him perfectly. But momentarily, we're going to shut this guy down, because now we want to come over here and talk to these guys. So in order for us to talk, this router doesn't have a serial interface. So we're not going to hook him through a fast Ethernet interface. I don't particularly like doing that, because I like using encapsulation. There's no serial interface, so we're going to shut the router down for a second, shut him down. Then we're going to give him a serial interface. Then we're going to come to this router, we're going to shut him down, and then we're going to give him a serial interface as well. Turn him back on. So, by the way, this side is the router. It always gets the DT. I don't know why it says DC there. Serial interface 0, come here and come here. These guys have no connectivity yet, but what I will do is I will come here, because I forgot to tell you guys what the network address of that WAN interface is. So the network address, let's see, network for WAN, wide area network, because these guys, this guy's in Atlanta, this guy's in LA. So they need a network address so they can communicate, and we're going to give them 10.10.1.0. But the subnet mask for this is going to be 30. So it's going to use 30 bits, okay? Because we don't want to have any extra IP addresses left over a WAN connection, because we don't want anybody jumping on the WAN connection. So what I'm going to do here is I'm going to go here. Oops, forgot to come back on. Let's cut him back on first. Give him a couple seconds. And while we're giving him a couple seconds, we're exchanging EIGRP routes, and the reason we're exchanging EIGRP routes is because this network is consistent of more than 3 routers, more than 4 routers. So it's 3 routers on this side of the frame relay cloud. That guy's in Canada, so that's why we're going to use the internet to get to him. I mean, we are using the internet with these 2, but we're going to have to use the ISP, a service provider, to get to this guy, and he's simulating the service provider, so that's why we're using him. Okay, the router should be back on now. And it is. It just booted back up. You see configuration dialog, whatever, blah blah blah. Come back. You do enable. We say config. We do interface 0, and we're going to give him an IP address of 10.10.1.1. But remember, I said /30, so we're going to use 30 bits up on this. Okay, 252. That's his IP address. No shut. It says down because the other side is down. Okay. Don't worry about that. So we're going to go ahead and give the serial interface over here the IP address as well, so we don't have to worry about it later. Enable, config, and we're going to say interface 0, IP add 192, not 192. Why am I saying that? We got the same network. Sorry about that. 10.1.2. 255.255.255.252. No shut. These guys should be able to talk to each other. So we're gonna ping. We're gonna do some testing of the connectivity here. Ping. Let's go ahead and ping that guy. Why do I keep doing that? And why did I? Hold on. I don't know why I didn't turn off the no IP domain lookup. and that's what it does when you don't do that. So we're gonna test it from the other side. Sorry, I don't know why I keep doing that. We're gonna come here. We'll say exit, exit. Well, no IP domain lookup, I believe it is. So he's not gonna be able to do that anymore. So we go there, yeah, exit king 10.1.2, and we have success. He can talk to that guy across the network, but he doesn't have a route, so he doesn't know about these guys down here. The only thing that's gonna talk is this. So let's go ahead and cable up the other side of this network. We're gonna cable it up. We're gonna give him fast Ethernet 0.0. We come down here, fast Ethernet 0.1, no, /1, and then we're gonna cable these guys up. But we have this time, we have 3 VLANs, and this guy will be able to talk to him on all VLANs. So we can do it 2 ways. I'm going to show you the 2 ways that we can do it in this video because I think you should know both ways. So I'm going to show you both, and then I'm going to do it the EIGRP way. Because with a default route, he can reach everything over here. He can reach anything, you know. So and the last cable is right here. So now it's getting a little bit more complex, and you can see it coming together now. Now these guys are in LA. Let me go ahead and put Los Angeles there so nobody gets confused, because I want you to know that these are 2 geographically different locations. Let's say LA. So we know that's LA. These are all these guys sitting at their desk. We got Bob here. We got Marty over there. We got Ken over there, and we got Cynthia right here. And the reason that they need to be on different VLANs is because what if this business in LA was what if this whole thing was a law firm or maybe even a school, 2 schools connected remotely. The school in LA belongs to a part of the district in Atlanta. The reason that they're on different VLANs is because what if VLAN 1, this virtual network, what if those are students, and what if this guy was a principal, and what if this was, I don't know, a janitor's closet? These students never need to get on there to be on. They don't need to be on the same network, you know. But they will be. The routing will allow them to talk, but they don't need to be on the same exact network. You see what I'm saying? So what we're gonna do is we got fast Ethernet 0/2 here. I moved that out the way just to verify. So we'll put 2 guys on VLAN 1. Okay, let's gonna put 2 guys on VLAN 1, one on VLAN 2, and one on VLAN 3. So the guy on VLAN 1, I'm gonna go ahead and give him config VLAN 1 interface VLAN 1 no shut. VLAN 1 is up, exit, come back out, interface FA2, switch port mode access, switch port access 2. Oops. VLAN 2. Oh, VLAN 1. What am I doing? I keep doing that. Access 1. You can't do that, so it's VLAN 1. Okay. Then we're going to go to 3. Interface 3. Switch port mode access. You only want him to access. And I'm going to explain that concept to you, why I'm putting switch port mode access first. Is because if you don't put switch port mode access first, you might get a disgruntled employee. This guy might get fired and might get mad. He might decide to take, or he might just want to mess up the network. So he can come and actually take one of his switches from home, bring it in, and hook it up to this port, and it will dynamically start trunking automatically. And what if he has different VLANs on there? It'll start sending different revision numbers. It'll cause a whole heap mess. But if by me putting an access mode on there, only PCs can go in there. So that's why I'm doing access mode. So we're gonna go switch port access VLAN 1. Okay, that's done. So that was what, port 3. So we're gonna say on port 4. We're going to give it a switch port mode access, switch up. One more thing I forgot. Again, I don't know why I'm so forgetful with this. VLAN 2 interface VLAN 2. VLAN 2 is up. VLAN 3 interface VLAN 3. VLAN 3 is up. So now let's go back out. Now let's go back in the interface context of 4. And we're gonna go switch port mode, switch port access, VLAN 2. So now that guy belongs to VLAN 2. So we got port 1, port 2, port 3, port 4. So we're gonna go to port 5. Let's go ahead and go to port 5. Switch port mode access, and then switch port access. We tell him he can only access VLAN 3. And notice that the line came up, line protocol. Normally, you can't really ping an VLAN IP address unless it actually has the interface up at that current time. Hold on, let me drink some water. All right, so now that we have all that up, let's get these guys' IP addresses. So PC1, he belongs to VLAN 1 on this router, on this network. He belongs to VLAN 1. So VLAN 1 is 10.1.1.1/24. So I'm gonna make it easy. I'm gonna give this guy an address of 10.1.1.2. But see how it defaults? See, it auto summarizes. See that? It gave me, I said I wanted 24 bits. It gave me 8. It defaulted to 8. But this network wants to, I need to be 24 bits, and not 8 bits. That's too wide of a network. I don't need that. So, .1.1.1. Okay. And this so I don't have to keep going into the thing every time. V1, 10.1.1.2. Because now it's getting a little bit tricky here. I know he's a VLAN 1 guy, but he's going to be there. I'm going to give him an IP address of 3. So you can't have the same IP address on every... Hold on. No two people can have the same IP address on the network. So now that's done. So he's good. So he's .3. I know he's .3 because he's .2. So now this guy doesn't belong to that network. He belongs to VLAN 2. So now I'm going to give him an address of... He's going to get an address of 10.1.2.2/24. And he has that address and he's good to go. And just so I can remember, because now I'm crossing over to different networks, we're going to say V2 guy 10.1.2.2. And just let me just double check and verify. .2.2, okay. Had to make sure I put the right address there because sometimes I get confused. So now we're on the last PC on this half of the network. So going on to the desktop, and this one I made it odd on purpose. 10.5.2.1, 255.255.255.0. Oh, it can't be .1. It has to be .2. Silly me. Hold on. .5.2.1. So now he has the address, and I'm going to copy that, and I'm going to put the address here. V3 guy, because he's on VLAN 3. And these guys are not going to talk. Those lines are still red. Why is this guy red? Huh. Let's knock that cable off and put it back. I don't know why that guy's red. We'll find out in a second though. Let's put a copper straight through cable back on 4. And put it here. And yeah, okay, I probably put it on the wrong port. Okay, so now we're getting down to the nitty gritty. Now we're going to go up, and we forgot again. This one right here has to be trunked to carry that tag across. So exit, interface, fast Ethernet 01. Then you'll say switch port mode trunk. He's going to carry all the VLANs across. So hey, he's going to advertise all these guys in different networks. So move him over here, get him away so no one gets confused here. So we're gonna go here, and we're gonna go enable. Then we're gonna go into config mode. Then we're gonna go to interface fast Ethernet 00, and then we're gonna say no shut. Bring him up. He turned green. Everything's a go. So then after we open him up, then we're gonna go and say interface fast Ethernet 0.0.1 because we want it to be VLAN 1. So we're gonna say encapsulation dot dot 1Q. Yep, VLAN 1 up. I don't have to do that. I don't know, just the switch in the router sometimes confuse me because you have to put VLAN, but on this one, dot 1Q means VLAN, so I don't have to do that. So I put that there. Then I go exit. Then I go interface FA00.2. Wait, no. And we want to go back into the interface. Let's go back into the interface. We go to IP address. We forgot to add the address there. 1.1.1. So we gave him an address. That guy's happy. So now we're gonna come back out. Interface fast Ethernet 0/0.2. So I'm saying encapsulation dot 1Q2. And we're gonna say IP add 10.1.2.1 / 24. And the reason I'm using 24 bits is because it kind of gets confusing when you have more than 24 bits. Then the third octet, you always have to remember where the network address is and all that. And I just really don't feel like going through that. So that's why I just use 24 bits. That's why everything on here is like 20. Everything on here is going to be 24 bits except this one right here. And I'm going to show you why probably in the next video. The reason that's one is not 24 bits because I want you to notice that you see how the router, when I was going into the IP addresses on the computers, the subnet mask is auto summarizing, and that's one thing that EIGRP does. It auto summarizes. So I want to show you what happens when it auto summarizes, because that is the network, but it automatically is going to assume that this is the network when in fact it's not. 192.168 is the network, but we'll get into that a little bit later. So anyway, we're going to go into interface. We're going to create another sub interface, .3. We're going to encapsulate him with .1Q3. We're going to give him an IP address of 10.5.2.1 with again 24 bits. Oh, forgot to put add, sorry. Yeah, sometimes I forget the commands. Know the Cisco commands, but working with HP ProCurve routers, I get confused sometimes. So let's see here. That's done. So now we have interfaces. Everything, all the interfaces are up everywhere. For some reason, this guy is down. Let's turn him back on. I don't know why he's down. Turn him back on. So he's good. So now he should be able to ping his default gateway. The gateway meaning here. And that gateway is the address that we just put on the router. So he should be able to ping and come up through here, and he should respond and say, hey, I see you, I'm responding, we're up, and I know you're okay. So let's go ahead and ping. And yes, he does work. So now we're going to ping the other default gateway that's on the router, which is not in the same network. And it pings successfully. So now what we want to do, we want to ping somebody in a different network, because these guys weren't supposed to talk to each other until I added the sub interfaces and trunked this. So we're going to ping the V2 guy over there, 10.1.2.2. So he's going to have to go through the router. He's going to time out at first. He times out, and then he replies. So now all of that works. So now what we have here, and everybody knows, it doesn't matter if you have a broad knowledge of networking or not, you know that a computer in Atlanta is not going to talk to a computer in LA. It just doesn't happen. So let's just try it out and see. Let's go here. And that guy here, this is PC1. in Atlanta. I'm going to try to ping PC1 in LA. So let's do a ping. Let's try it out. 10.1.1.2. Nothing. Not going to get anything. Timeout. Another timeout. Another timeout. And another one. So we know it's not going to happen. But now I want to show you something. I did say I was going to do EIGRP routes, and I am going to do it. But the part that I want to show you, which is kind of important, is that if let's just say none of this onto the right, none of this to the right was here. Let's just say none of it was there. I wouldn't need to do that. I would simply need a default route. So let's just go ahead and add a default route here, and let me just show you what a default route, IP route. When we do a default route, it's just 0, 0, 0, and that's saying anything. Unlike a wildcard, man, it's kind of an anomaly. But let's see here, 0, 0, 0. He has a route. So basically, what I just told him, that's a route. 0, 0, 0, 0, 0 with a subnet mask of 0, 0, 0, 0, 0 coming out of that interface, this interface here. So basically, what it's telling Atlanta is, hey, if I can talk here on this network, but if I ping or try to talk to anybody who doesn't belong to anything on here, send it out here, send it out that way. And when it hits him, he'll figure it out, and then it'll get down there. So let's go to LA and do the same thing. We're going to give him a default route too. So we're going to say IP route 0, 0, 0, 0, 1, 2, 3, 4, 0. And he has a default route out. So both of these guys have default routes. So now let's try to ping. So I just want to show you that. We're still going to do EIGRP, but I just wanted to show you that part though. That part was pretty significant. And the router should pick it up. He's not picking it up yet. Hold on. Yeah, he didn't pick that up yet. So let's do this. Let's go back into the router and find out why. He still didn't pick it up. So we'll go back in and we will investigate. And maybe, you know what? Maybe it's because of this. Let's do this. Maybe I shouldn't use a sub interface. Maybe I was being lazy. Let me not be lazy anymore. Let's do this. Let me go back, double check on his ping. Nothing. So yeah, let me just not be lazy. Let's try it a different way. And the other guy's address was 10.10.1.2. So let's do that. Let's just do that. And let's just give him a route. And it's probably not happening because I didn't give him a route to come back. So let's do that. So let's try it again. Let's see if the guy in Atlanta can talk to the guy in LA. I mean, this is all a part of the process. A lot of times, if it doesn't work, then we'll do it again. But I really just trying to show you a default route without going on, without implementing EIGRP first. And sometimes these are things you have to go through. So let me just keep doing this and we'll get connectivity soon. This is why I like dynamic routes. I don't like static routes. They're more simplistic, but at the same time, it can be a pain. So he's going to come out. He's going to come here and he's going to go down there. Okay. Let's go back out again. Let's get Atlanta and LA talking. This is all a part of the troubleshooting process to figure out why this is doing this. So let's go here. Just come out. Let's do a show IP route. So basically he has a static route. I mean, I'm really trying not to be lazy. Like, it's just really becoming to become a task. So let's just do it. Okay, fine. I'm gonna do this. I'm gonna go IP route. 192.168.1.1, and then it's gonna come. He's gonna go out on 10.10.1.1 and complete command. Oh, I forgot to put the subject mask on. I really want to come to the network, so I'm not gonna put that because that's not a network. And then we're gonna leave out on 10.10.1.1. So I mean, I try to be lazy, try to be fancy, but apparently it didn't work out too well for me. So let's give it another IP route of 2.0. And he has on his route. And I mean, this is not bad. I mean, it's not filling up the router's routing table or nothing. I mean, it's more easy to put an IP route out there like that and get it going like that. But we'll do some troubleshooting and figure out why later. I mean, I really didn't want to do this. So let's go to Atlanta and give it a route to these guys' networks. As a network administrator, you probably don't want people doing this because if people get into the habit of doing this, then what happens is, like I said before, the routing table can get big and it says inconsistent address and mask. Oops. Why do I keep doing that? Okay. So we're doing another route to 10.1.2.0. And one more route to 10.5.2.1. Oh, .2.0. And you probably wonder why I'm putting 10.1.1.0 and then 255.255.255.0. This doesn't match this, and the reason it doesn't, I'm putting the network address here. That is the first. You can't put a network address on the interface, so that's why these ending dot ones. That's why I put them like that, just in case you want to know. So I come out of there. Okay, so now let's do a show IP route. All right. So static routes there. No, there's no 10 network in there, so it is the route is there. And has a route to get back. So now let's try to talk to that guy. So we'll worry about the default route later. Don't worry about it. So this is ping 10.1.1.2. Now the router should figure it out. And this is so crazy that it is still not picking up my signal on the other side. I can't believe it. Hold on. Something's going on between these two routers. We'll figure it out. Hold on. Do show IP route. And he has a static route to that guy via 10.10.1. Do show IP interface brief. The protocol is up. Show IP interface brief. And I believe I found out why it's not working. Okay. That is up, and that is up. But for some reason, my sub interface isn't there anymore. So let's find out why. Um, those guys were pinging and talking earlier. I guess because I shut the router down without saving the configuration earlier. Wow. So let's do this. Config. Can't believe I did that. And the sub interface wasn't even there anymore. That's what happens when you shut a router down. Remember we shut it down earlier to connect the serial cables. I knew it wasn't crazy. Hold on. Right, ma'am. You have to do it every time. Show IP interface brief, and it is there now. So yeah, I did that and I messed up earlier. So, huh? These guys should have some sort of connectivity now. And let's check this guy. Let's do a do show IP brief. Oops. Up. Protocols up. Down. I want that to be down. VLAN 1 down. That's on the router. So, I mean, I don't have to give the VLAN 1 address. The VLAN address on the router is for management purposes. So, we don't have to have that up. The VLANs are up on this side. So, this guy can talk across the network. So, let's just double check. Let's do a basically what we're going to do is we're going to just troubleshoot this real quick. Let's do this. Let's do a trace route to 10.1.1.1.2. Trace. What's on the PC? Trace RT. So we're going to trace the route and find out where we went wrong at. Okay. So he times out here. I'm going to go back here. We're going to check his default gateway. Let's check his default gateway. The reason it's not working is because router 1 has some sort of snafu. It's nothing with router 2 LA. So we're back in router 1 again to figure out why this is doing this. Okay. Back in router 1 again. He can't even ping his own default gateway. And the reason he can't ping his default gateway because I turned the router off and forgot to turn it back on again. Hold on. That's what happens when you. Everybody, don't be mad at me. I turned the router off and I forgot that I had the right method. I mean, this is why It's just not good. So that's probably why he wasn't getting any connectivity. Hold on. So now he should be able to ping his default gateway. Yes, and he can't ping his default gateway. So now that's what happened. I should have never turned the router off. Well, I had to. All right. So let's try to talk to the LA again. Oops. And he talks to the computer in LA. So yeah, basically what we learned today is hit right mem before you turn the router off. I forgot. I'm sorry. And he's talking to the computer in LA. Let's try to talk to this guy in LA. 10522. So let's go ahead and try to talk to this guy. 522. And he works perfectly. They have routes to go back and forth, and he's replying. So we successfully made computers talk from LA to Atlanta. So now let's go out of this. Exit. And I can bet your bottom dollar that's why my command didn't work earlier. No IP route. What was it? Atlanta. Let's say 10.1.1.0. Let me put the subnet mask in there. And 1.2 2.0 10.5.2.0. And I just want to show you how default routes can help. And we can go back to IP route again and put this in, and it should work because I didn't turn the router off this time. So let's do show IP route. And notice I only have the statically assigned default route there. So I'm gonna come out of there. I'm gonna go to LA. I'm gonna remove all his routes to Atlanta because I gave him routes. I'm gonna remove them. So no IP route 192.168.1.1. Forgot 0. Sorry. And we're gonna go. Okay. Both of them have default routes to get out. He's got default route, and he still pings. Still pings across. Okay. So now we're gonna go ahead and we're gonna take the default route out. We're gonna take the default route out, and now we're going to implement EIGRP. IP route. So that route is out. So now those were statically assigned routes, and that I'm going to use now is EIGRP is like a hybrid. That's what they call it. They call it a hybrid distance vector protocol, but it really kind of sort of works like a link state. I guess it's a super distance vector protocol, if you will. So we're going to say router EIGRP1, and then we're going to say we're going to start advertising networks. We're going to advertise 10.1.1.1, 10.10, if you will. Advertise network 10.1.2.0. Advertise network 10.5.2.0. So basically what I'm doing on LA, I'm advertising these networks. It's going to advertise across this interface. So I think I can do interface. It doesn't really see those routes. So So those networks are advertised, and we also need to advertise network 10.10.1.0. Advertise the network as well. And I'm going to show you a little trick after I'm done with it. So bear with me. EIGRP successfully placed on that router. So we're going to come on this router. I'm going to say router EIGRP1. They both need to have that same number. You have that same number 1. So if I put 2, they're not going to work. So we're going to say network 192.168.1.0, network 192.168.2.0. Those two networks are there. And we're going to say network. Now watch as this magic happens. 10.1.0. Notice EIGRP neighbor .2 is now up in new adjacency. So now these are neighbors. So do show IP EIGRP incomplete command. Let's just do this. Let's come out of here and just show IP protocols. I spelled it wrong. Hold on, sorry. Protocol. Okay, so in Atlanta, what we're doing is we're routing for these two paths. It has a gateway of getting here. The distance is 90, and that is the administrative distance. So that's basically just a metric. You could tune it. So now these routes are now advertised across the network. So now he can still ping and talk to the other computer. So let's try it out. Ping 10.1.5. Let's do 5.2.2. That's the furthest one away. It's crazy math. Okay. He's still talking. But what I want to show you before I end this video is something that EIGRP does that's kind of frowned upon. So we're gonna do let me say show IP route. And what it did was, well, it gave me these routes, but it gave me these routes. Boom, is a summary. Null, 0. It gave me a summary and it did that. So basically what EIGRP does, it advertised this route to me with a /8. So it encompasses all of these things, and that can be dangerous when you have a very large network, because what if I start having different subnet masks? It could be very dangerous. So I believe I can do this. Let me see if I can remember the command. Hold on real quick. Router EIGRP 1 no auto summary. Okay, no auto summary. So it doesn't summarize the route anymore, which, like I said before, so it's not going to summarize that route. It's going to summarize, okay. And this one, I'm going to go back in and see the neighbor adjacency kept going up and down on here. Goodbye receive, and then new adjacency, it went down, it came back up. So no auto summary. See how I said new adjacency? So I say exit, do show IP route. It just says that that's there, and it advertised 2 routes. It doesn't advertise. So let's go back here. Let's go back here again. Do show IP route. No summary. 4 routes. So there you have it. That is the conclusion. What I've done successfully is create 3 VLANs on this switch. All 3 of these can talk to each other within this network in LA. This network in LA has a route, a dynamic route, if you will, to get to Atlanta, and can talk to both subnets in Atlanta, effortlessly. So we're gonna call this Atlanta to LA. And stay tuned for my next video. We're gonna connect LA to Chicago, and then I'm gonna blow your mind with the frame relay cloud to get to Canada. And we're gonna cause all one school district, and all these schools are gonna be able to talk to each other. Thank you for viewing, and this is my first video.